Evening, juniors and friends. We'll be starting the stream soon. Meanwhile, please make sure that all your classmates are joining and send the link to everybody. We're also streaming this on YouTube, so you can send the YouTube link to others also. We'll start the stream soon.
Our hearts beat.
Hello, am I audible to everyone? Please just type in the chat. I'll give a reaction. Okay, okay, thank you. Let's start the session. Good evening to one and all present in the Zoom meeting and Google Meet and YouTube Live. Today, I and my friends represent him GDSC VSSUT Burla. This is a 4-day session on AIML. Actually, it's a workshop, you can say, because you will be getting tasks and you have to do it. So, it's a workshop on artificial intelligence and machine learning, we'll be starting with Gen AI and take a look at some Python, then some machine learning, and at the end, we'll also go through TensorFlow. Today's session number one. Uh, Today's topic is generative AI, also known as Gen AI, commonly called. So, welcome all. Let's look at the speakers of the day. Myself, Kaushik Kumar Das, and I'm a community member at GTSC VSSUT.
I am Anshuman Mishra. I am a community member of GDSC VSUT.
I am Tasha Garwal, community member at GDSC VSSUT.
I am Archana Swai, a community member at GDSC VSSUT.
Together, we are all going to give you a detailed description on what generative AI is. Don't worry, it will be a beginner friendly session. We'll not look at some hefty codes, we'll just look at more on the theory side and it will be easy understanding. I hope it's fine for all of you and you all enjoy the session. There are some ground rules that I want to state from the beginning. Please don't unmute yourselves unless you said so. That is, you can unmute yourselves in the question and session only, or if you have any doubts, you can raise your hands. We request you to use the chat box for any queries that you have, and please don't spam in the chat box or in the YouTube comments, as it will disturb not only you but us but everyone. Let us know if you are having any issues with the audio or video in the chat, or you can raise your hands in that concern. We'll try to sort it out as soon as possible. If you've got any questions about the session, you can write it in the chat or you can speak to us in the question answer session. And with diverse opinions coming in, we expect you to respect each other's thought and don't fight in the chat. Let's look at the agenda for today. We'll first have a primer on generative AI, then we'll look at the Gen AI timetable. Along with that, we'll go into the implications of large language models. It may sound very difficult now, but I'm sure you will understand LLMs pretty good. Exploring the diverse landscapes of generative AI output, then we'll show you some of our projects and then some use case scenarios. Along with that, we'll discuss about the challenges, limitations, and coming to the end, to the conclusion, and the question answer session. Please make sure that you stay till the end. We have a good surprise for you at the end. So I think we are ready to start. Let's see. Generative AI. In the world of artificial intelligence, a groundbreaking technology is taking center stage. Generative AI. Imagine a world where machines can create compelling text, stunning imagery, and even entertaining videos in a matter of seconds. This is the promise of generative AI. Generative AI is a branch of artificial intelligence that focuses on creating new and original content. It involves training machines to learn patterns and generate new data such as images, music, and even texts. Let's have a historical flashback about generative AI. Generative AI is not a newcomer to the scene. Its roots trace back to 1960s when chatbots first introduced the concept. In the generative AI's evolution, it started as in 1957 when a linguist, Noam Chomsky, published Synthetic Structures, his article, in which he describes the grammatical rules for parsing and generating natural languages. In 1966, MIT professor Joseph Weizenbaum created its first chatbot in the human history named Eliza, which just simulated conversations with a psychotherapist. In 1985, computer scientist and philosopher Julia Pearl introduces Bayesian networks causal analysis, which provides statistical techniques for representing uncertainty that leads to methods for generating content in specific style, tone, and length. Then coming on to 1989, Yan Shu Len and Yoshua Benjoy demonstrated how convolutional neural networks or CNNs can be used to recognize images. CNNs might seem a little intrusive to you, but I'm damn sure after the entire session, I guess it's in the third session, you'll learn how CNNs are implemented. We'll have a great fun there. Then next come to 2011 when Apple, that big tech giant, released Siri, its voice powered personal assistant that can generate responses and take actions in response to voice requests. You all must be familiar with Siri, like, yeah. In 2014, research scientist Ian Goodfellow develops generative adversary networks of GANs. We'll study them in the third session as well. Then coming to 2021, a big thing appeared. OpenAI, tech giant, introduced its first DALL-E DALL-E model, which can generate images from text prompts. Its name is a combination of Wall-E. It's the name of a fictional robot. I guess you all must have seen the movie. And the artist Salvador Dali. In 2022, researchers from Runway Research, Stability AI, and CompuVision released Stable Diffusion. It's very popular now. And finally, at the November of 2022, a groundbreaking discovery by OpenAI when it releases ChatGPT to the public. It is a chat-based interface which uses GPT 3.5 LLM, which was discovered by OpenAI itself, and it attracted more than 100 million users within 2 months, representing the fastest ever consumer adoption of the service. We'll talk about LLMs and ChatGPT later in this session, but I hope everyone is familiar with ChatGPT. Guys, you can interact in the chat. This now newfound capability of generative AI has opened up a world of possibilities, from enhancing movie dubbings to creating rich, immersive educational content. But with great powers comes great responsibility. We'll talk about this later. Two recent technological advances have propelled generative AI into the mainstream. First is transformers and breakthrough language models, also known as large language models. Transformers are a type of machine learning which allowed researchers to train ever larger models without exhaustive data labeling. They brought a new concept called attention, enabling models to track connections between words across vast amounts of text, analyzing not only words but also codes and DNA of biomolecules. Yet the progress so far hints at a transformative future. Generative AI could revolutionize industries like writing code, designing new drugs, developing products, redesigning business processes, and transforming supply chains. As we stand on the brink of a new era, generative AI holds the key to unlocking full potential of artificial intelligence and machine learning. The journey has just begun, and the possibilities are limitless. Generative AI is shaping the future, one creation at a time. Now, coming to how generative AI really transforms ideas into reality. Welcome to the world of generative AI where innovation meets imagination. Ever wondered how this cutting edge technology works? Let's dive into the fascinating realm of generative AI and unveil the magic behind its creative prowess. Generative AI begins with a prompt, a spark of creativity that can take the form of text, images, videos, or even musical notes. It's a starting point for a journey into the unknown, where the AI system processes your input and conjures up something entirely new. Behind the scenes, powerful algorithms come into play. These algorithms, fueled by data and trained models, work tirelessly to generate content in response to your prompt. Whether it's crafting essays or solving complex problems or creating realistic fakes from images or audio, the possibilities are boundless. You all must be familiar with the new deepfakes arising in the social media, starting from the deepfake voice of Cristiano Ronaldo or our Prime Minister to the deepfake videos of Joe Biden, Queen Elizabeth, etc. In the early days, interacting with generative AI was a complex process, requiring data submission through APIs and intricate programming. Developers navigated through specialized tools, and now it's a very easy thing. Like we have to just write few codes in Python. We'll look at them later in this session. But times have changed now, and it has become a very easy step to just train AI models and do anything you want to do. Now I would like to pass to Archana to say about large language models. Archana, please.
Thanks, Kaushik. So let's first learn some vocabs. Generative model. So what are generative models? An ML model that produces content including language, code, imagery, music, video, etc. Means generative models are a class of machine learning models that excel at producing new content rather than just analyzing existing data. So, how they do this? They do this by learning the patterns and distributions of real world data and then using that knowledge to generate new samples that closely resemble the originals. Large language model. Machine learning models that are really good at understanding and generating human language. Large refers to both size and complexity of the neural network itself, as well as the size of the dataset it was trained on. Can also be used for non generative language tasks like classification. So, this means a large language model, LLM, is a machine learning model designed for advanced language understanding and generation. It is characterized by a large and complex neural network and is trained on extensive datasets. LLMs excel in both generative tasks like text creation, image creation, etc., and non generative tasks such as classification and sentiment analysis, etc. Transformer. The neural network architecture underlying most of today's generative models, and more widely, most SOTF ML models published by Google in 2017. Means the transformer is a neural network architecture that forms the basis for many advanced generative models, including state of the art SOTA, state of the art machine learning models. It was introduced by Google in 2017. In simple terms, it's a fundamental structure that revolutionized how models understand and generate informations. Next slide. So, what are large language models? ML algorithms that can recognize, predict, and generate human languages. Means machine learning algorithms designed for language tasks can do three main things: recognize, predict, and generate human languages. First is recognize. These algorithms can understand and identify patterns in human languages. For example, they can recognize words, phrases, or even sentiments in a given piece of text. Then, second is predict. ML algorithms can make predictions based on language data. For instance, they can predict the next word in a sentence or can estimate the likelihood of a particular outcome in a language related task. Then, third is generate. These algorithms have the capability to create new human like language. This could involve generating sentences, paragraphs, or even entire articles based on the patterns and structures they have learned from training data. LLMs are pre trained on a petabyte scale text based datasets, resulting in large models with tens to hundreds of billions of parameters. Means large language models, LLMs, are trained on enormous datasets, often in the order of petabytes. This training process results in models with immense complexity, typically comprising tens to hundreds of billions of parameters. LLMs are normally pre trained on a large corpus of text, followed by fine tuning on a specific task. Means LLMs are typically trained in two steps. First, they undergo pre training on a vast amount of diverse text, learning general language patterns. After this, they go through fine tuning on a more specific task. So basically, it's a two-step process. Means broad learning of language followed by specialized training for a specific task. LLMs can also be called large models. Previous slide. LLMs can also be called large models, includes all types of data modality, and generative AI, a model that produces content. Means large language models, LLMs, can be referred to as large models because they are not limited to just text. They can handle various types of data. Additionally, they fall under the category of generative AI as they produce content. Next slide, Kaushik. So, why are large language models different? LLMs are characterized by emergent abilities or the ability to perform tasks that were not present in smaller models. LLMs are known for emergent abilities, meaning they can do tasks that smaller models couldn't. In simple terms, they have the talent for performing new and more advanced tasks that were not possible with smaller models. LLM's contextual understanding of human language changes how we interact with data and intelligent systems. This means they understand the language more effectively, making interactions with data and smart systems more intuitively and contextually informed. LLMs can find patterns and connections in massive disparate data corpora. Means large language models, LLMs, have the ability to identify patterns and connections within extensive and diverse sets of data. In simple terms, they can find meaningful relationships and trends in massive datasets. Next slide. Here is a popular meme that says the hottest new programming language is English. I hope you all know this. From now, I would like Anshuman to carry forward. So, Anshuman.
Thank you, Archana. And next slide, please. In this slide, we will learn about the role of Google in generative AI. In 2017, Google invents Transformer. Now, what is a transformer? As you have all heard about ChatGPT, the GPT in ChatGPT stands for Generative Pre-trained Transformer. These transformers enables the machine to understand, interpret, and generate human language like never before. That's why the transformers are a big deal. Coming to 2018, Google invents BERT, which helps the search engine to understand the intention of the user. For example, if one types apple, how does Google search engine knows it's the company or the fruit? Here, the birds help. Now coming to AlphaFold, it can predict the structure of proteins, which is a big breakthrough in medical science. And AlphaFold runs on Linux operating system only for now. In 2019, T5 LLM is launched, which is text to text transformer, which is based on C4, which is obviously not an explosive. It is a dataset known as Colossal Clean Crawled Corpse. Then in 2021, Lambda is launched. In 2022, Palm is launched, and in 2023, Bard is launched, which was first trained on Lambda, then Palm, and now it is trained on Gemini. Next slide, please. Now, I would like to invite Kaushik to uh, say something about LLMs.
Yeah. So everyone must be wondering what LLM is actually. Here is a slide that we have prepared about what LLMs are, and we will explain it to you. So we have the large language models are basically models, AI trained models, in which we can give some input and it will predict the output depending on the model that we have trained on. It is similar to us human brains, like we have been trained in English. So here is a simple example. Honesty is the best. So honesty is the best is the given input that we give, and the LLM has to predict what will be the output after that. Like simple English, this LLM has been trained in English, we can assume, and as in simple English, we will have multiple possibilities. We have multiple possibilities like honesty is the best policy, honesty is the best way, honesty is the best approach. But according to English and us ourselves, we tend to usually accept the option that honesty is the best policy, and we train the AI model as honesty is the best policy. So the large language model will return policy as the answer, as it is the most likely next word that is possible after honesty is the best. Then we have other possibilities also, like honesty is the best way, but it's not the best possible way to describe. So the large language model will simply return honesty is the best policy. We have trained large language models, like us humans have trained large language models to identify nouns, verbs, and work accordingly and give the results according to simple English. Like the way we can speak is the way that LLMs can generate outputs. Suppose we give a prompt, the text you feed to your model. That is, suppose we give it some example to generate an essay on beers, and then we design the prompt. That is prompt design. It means the art and science of figuring what text to feed your language model to get take the behavior you want. That is, we feed our large language model some input. We train it before words so that we can expect some static behavior from it. This is an example of large language model. We give the large language model like GPT 3.5, suppose from ChatGPT. We say write a poem about cricket, and it gives lines and lines of poems on cricket. Now let's see some examples. Let's convert the French English sentences to French. We say that peppermint is called menthe poivre. This is an input that we have given. That is, we have trained the large language model that peppermint is known as menthe poivre. Then we have trained the model that desert cactus is cactus de desert, and then potato is pomme de terrace. We have trained the model in such a way that it has to predict the answer. That is, what will the French term for onion? And it predicts simply oignon. That is, we give a user input. First, we train the model. Then we give a user input, and at the end it returns something. In this case, the French of onion, that is onion. Let's take another example. We have two programming languages, suppose Python and JavaScript, and we train the model to convert Python to JavaScript. That is, when the user says to convert Python to JavaScript, the LLM will search its trained model for the training. That is, in this case, the Python program for print hello world has a syntax like this: print hello world with double quotations. And we have trained the model that the JavaScript output will be console.log in parentheses and quotations hello world. That is, we have trained the models that there is a difference between Python and JavaScript. In Python, it simply writes print this, and in JavaScript, we train the model that to print in the console, we write console.log hello world. And then we give the LLM a question, that is to convert the Python for x in range 1 to 100. This is a syntax for loop in Python, and we want the JavaScript to answer us. We want the LLM to give the result in the JavaScript syntax for loop, which ranges from 0 to 100. This is an instruction, this is an example, and this is the input that we give, and this is the output for var x equal to 0, x less than 100, x plus plus. This is the output, that is the Python script for x in range 0 to 100 will be equivalent to for variable x equal to 0, x less than 100, x plus plus in JavaScript. So this is a user input, and the answer that we get is the output. This is a simple example also. Like the user trains, who are you? Bot says, I am Sachin Tendulkar. This is a dialogue based large language model training. We have trained it as if when the user says, who are you? The bot will say, I am Sachin Tendulkar. And then the bot will give all the answers as if it is Sachin Tendulkar. That is, it has taken a dialogue form. This is the prompt. This is also a similar prompt. A few observations from the previous slides that we got. Our LLMs are designed to predict the next word in a sequence. They are not required to be truthful when doing so, but they just want to predict. Like the LLM is not Sachin Tendulkar, but we give it input that it should work like Sachin Tendulkar, and it just works like Sachin Tendulkar. It does not have to be truthful. It just has to predict the next words in the sequence. And LLMs can generate plausible looking statements that are irrelevant or factually incorrect. Suppose we train a model somehow and we feed wrong information into the model. The model does not have any idea about what the real life conditions are. So if we give plausible looking statements, irrelevant statements, it will give factually incorrect outputs. And also hallucinations. LLM can generate false statements. As I said, if we give wrong information in the training set, the LLM will return some false statements only. We looked at this example. Now suppose there are two strategies. First is the decoding strategy. When we give an input, the sky was full of dash. There are many possibilities. All the possibilities are actually right. There is no wrong possibility. But in this training model, the more the number of inputs that we give, the model actually generates a probability for each of them. That is, stars has 0.5 probability, clouds has 0.23 probability, birds have a little less probability, dust has very less probability. So the LLM model decides which one to pick. The highest probability word will get selected and will get the output as the sky was full of stars. In a random sampling, what happens is that in all of this, it chooses some random thing. Like the sky was full of, it will randomize the entire array as supposedly the list. The sky was full of, there is a list, and it will randomly generate one of the elements of the list. That is, it could sometime return cloud, it could sometime return dust, it could sometime return stars, it could return anything. This is called a random sampling. Next, let's come to temperature. A temperature is used to tune the degree of randomness, not in the case of degrees Fahrenheit. Here it just suggests the degree of randomness. That is, the lower the temperature we give, the less random it will be. And the more the temperature we give, the higher the randomness will get. That's just a way to represent random sampling that we just talked about before, and a greedy decoding that we talked before that. So this is a UI from Google Vertex. Uh, Here we can choose the top K and top P. Top K means the temperature, and top P represents the probability. We'll talk more about this in the last session actually, when we read about the TensorFlow, and session 3 also, and we'll learn more about machine learning. I hope you all got a clear idea from LLMs and how they work actually. Uh, could you all just react or write in the chat if you have any doubts till now? Any doubts or queries? You can just raise your hands or write it in the chat.
Okay, so someone asked about what is TensorFlow. Uh, TensorFlow is a framework. You will learn in our upcoming sessions that it is a framework, just like in web designing, there are some frameworks like React. It is also some type of framework. This is just a beginner level session, so we will not go to the deep in TensorFlow, but you will know in upcoming sessions. Any other doubts?
I hope Priti Padma you got your answer to what is TensorFlow. We'll talk about that in the later sessions. Any more questions you can ask it in the chat or raise your hands. I guess we'll just run forward, and if anybody has any doubts, you can ask it in the chat. So I would like to pass the discussion to Ansuman once again. He will explain more about the examples, we can say, of generative AI. It's an interesting part. So, Ansuman.
Okay, thank you, Kaushik. Uh, Conversational evolution. In this slide, we will learn about conversational evolution. These text-like generating AIs are trained on LLM, which have a large amount of data, generating human-like conversation thanks to generative AI. For example, you have all heard about ChatGPT and Google Bard. Let me just show you. You have already known, but just let me show you. If someone have not heard of it or used it, let me show you. Okay. Is it visible? React in the chat, please. Now I will enter some prompt in this chat GPT. Give me some suggestions to enter here in the chat. Okay, give me some suggestion. Okay, we will start. So here I will type what is the greatest number. So there will be a response like there isn't a single greatest number, but in mathematical point of view, there is infinity, such type of. Now we will go to bird and enter the same prompt, just like uh, okay. Here is the response. You can see that the both of the response were different because ChatGPT is trained on different large language model as Kaushik and Archana have said before, and Bird is trained on different LLM. Now, uh, slide please. Next slide please. Kaushik. In this slide, we will discuss on future of art with generative AI. Although AI can't fully replace the artist but can be a guide to them. With the help of this tool, we can create art forms just in few seconds just by typing it. Let me show you an example to generate an image using Playground AI. Let me share my screen. Okay. Okay. Here uh, I will enter something like anything you can enter. I am entering like horse in space. Okay, and I will generate. We have to wait few seconds. Does anybody have any other suggestions what to generate? Here is the image of dog in space. We can add space suit here like 4K realistic. Okay, feel free to uh, share your opinion what to enter, what to not. It will be interactive. See, this is more realistic and 4K type. Helicopter in water. Okay. Okay. Something abstract. Okay. Okay. Helicopter in water. Okay. Let's generate it. Helicopter in water. Obviously, we have to wait a few seconds, but it is nothing compared to the uh, uh, drawing it by itself. So here is the image, helicopter in water, and After it, I am going to show you some projects. Uh, so simple project these are. Uh, this is a project based on the Open API key, OpenAI API key, where I have integrated the model GPT 3.5 Turbo, and I have asked, "How are you?" And this is the response. I hope all of you can see it. As an AI, I don't have any personal feelings, but I am here to help you. How can I assist you today? Here I can change it. What is the color of water? Hmm. Here is the response. As you can see, the color of water is typically colorless or transparent. However, it can appear to be blue or green in larger body, such as ocean, lakes, due to reflection of scattering light. And for second project, all of you try to recreate this project. This is a easy project, so I hope you can do it. Not more more code required here. For second project, I have made another project using the module OpenAI and Gradio. What does Gradio do? It takes the project that you have created with code, and it makes a website out of it. Here I have named the website as the Pro. You can name it anything, and I am going to share the link. I am going to share the link here to you can experiment on it. So if I here same input, just like what is the color of sky? Okay, it will take some time to process it. As I mentioned earlier, sky is really clear day. Yes, this is the response. If you flagged it, uh, it will save the response and question in a CSV file. Here, user input, output, flag name, username. What is the color of sky? Here is the output. You can see here. Okay. For uh, now, I will uh, I will request Tasu to take over from here.
Thank you, Anshuman. So now it's time to see some applications of GenAI. The GenAI interprets the genomics. First of all, we know that AI are trained under large data sets. So, in the field of medical science, especially in genomics, a field in which we study about DNA, scientific study of complex diseases such as heart disease, asthma, diabetes, cancer, and it is found that these diseases are typically caused because of genetic and environmental factors rather than by individual genes. So, with the help of AI, we can analyze and pinpoint various genetic variations that may lead to certain diseases in future. And with a better understanding of individuals' genomic profile, we can have personalized treatment plans, and it also helps to identify potential drug targets so we can have targeted therapies. And indeed, this is the new beginning of medical science. Secondly, we have GenAI can analyze vast amount of historical and real-time financial data to identify patterns, trends, and market dynamics. So it provides us optimized trading algorithm and strategies that adapt to changing market conditions. It also enhances the risk management by assessing and predicting various types of risk, and it also plays a crucial role in detecting and preventing fraudulent activities by analyzing transaction patterns, user behavior, and other relevant data. So this contributes to have a improvised and supervised security of financial transaction. Next, I think this is the coolest application of these LLMs in the field of education. This type of AI tools give us access to our own personal AI assistant, and this means every single student will have access to their own personal AI tutor. With the LLMs, we have the ability to personalize education to our students' needs, helping them in finding answers to questions quickly, as well as making sure that they understand how to get to a particular solution. And it also takes care of students' strengths and weaknesses. And I'm sure that in coming year we will see more advanced AI that will be making learning much easier and interesting. Next is the collaboration of AI and arts. The collaboration between AI and artists has given rise to a new and exciting interaction of technology and creativity. Generative arts. We can create visual arts by generating images, like now Anshuman has shown, paintings, or digital designs. Help us to explore new aesthetic possibilities and have unique pieces of arts. And it can also be used to compose music by learning the patterns from existing composition or generating entirely new music piece. And the NLP algorithms also enables AI to generate creative writings, poetry, or even collaborate on storytellings. This is a amazing combo of technology and creativity. The next we have the integration of Gen AI into customer interaction has indeed transformed the way business engage with their customers. Gen AI powered chatbots can provide instant responses to customers' queries, assist with common issues, and guidelines through process, and also provide human like interactions. And the best part is its 24/7 availability. For business with a global customer base, it can receive assistance regardless of their time zone. And AI can analyze customer data to personalize the interaction by understanding the customer's preference, purchase history, and behavior, so providing a more personalized experience. And this AI had also made possible of sentiment analysis, allowing business to gauge the sentiments behind customer messages. By understanding whether a customer is expressing satisfaction, frustration, or other emotions, we can respond appropriately and improve overall customer satisfaction. And that's the prime motto of any business. So, so far we have seen some applications of Gen AI, but we know that advancement in technology come with application, then it also come with some challenges and limitation. Such is with Gen AI. So let's look have some challenges and the limitations AI is facing. First is ethical concern, that is data privacy. Generative AI models often requires large data sets for training. These datasets may contain sensitive information, raising concern about privacy. There is a risk that individual persons' use data in training models might be compromised, leading to privacy violations. Protecting users' data and ensuring their protection regulation is very crucial. S- And the next challenge we are facing is bias in training data. We know that AI are only models. If we train data on biased data, then model can perpetuate and amplify those biases in its output. Reproducing biases from training data can result in discriminatory outcomes, reinforcing existing societal stereotypes. And this can also lead to unfair treatment and unequal opportunity for certain individuals or group of peoples. Next is low quality. The generation of low quality or inaccurate outputs by generative AI is a significant concern, especially in critical applications such as healthcare or finance can have severe consequences. Ensuring quality control, testing, validation, and human oversight become crucial to prevent potential harm. Generative AI systems may produce outputs that do not meet the desired quality standards or accuracy levels. But in certain fields, ethical consideration and a commitment to the highest standards of quality are paramount. So we need very careful attention. And the next is regulatory frameworks. As the deployment of generative AI indeed introduces legal and ethical challenges that requires careful consideration and the development of regulatory frameworks. Generative AI can create outputs that may resemble existing intellectual property, leading to questions about ownership and infringement. Therefore, determining the ownership of AI generated content is very crucial. And the most important thing is determining the liability. Means if an AI system generates a content that causes harm or violates law, who will be liable for that? So, establishing accountability for AI generated output is very essential. Regulatory framework should define responsibilities for developers, users, and the organization deploying generative AI to ensure ethical and legal use with appropriate means in case of misuse or unintended consequences. I'm sure that you all must have realized that the deployment and development of generative AI comes with various ethical concerns that requires various careful considerations and regulations. We need to have a balancing innovations, protection, and accountability. So, this was so far our session. Now, look what we have learned so far in our session and what are the key takeaways for you. So, we started with exploring the fascinating world of Gen AI, how it evolved with times, how it works, the commonly vocabs of generative AIs like LLMs, large model, and transformers. Then we saw how models of Gen AI are different from existing models. Then we see text generation AI, our OpenAI chat, Google Bard. For image generation, we saw OpenAI DALI and many more. Then we saw that it holds immense potential across various domains. However, with great power comes great responsibility. As we delve into the possibilities of Gen AI, it is very crucial to consider the ethical implications, ensure transparency, and work towards a balance between innovations and ethical uses. Last but the not least, the field of generative AI is dynamic and there is always more to learn. We all need to stay tuned and about the advancements, ethical guidelines, and best practices is essential for development and implementation of Gen AI. I hope you all must have got a good idea what is Gen AI, how does it works, what are its application, what are its limitations and challenges. So it's now time to have your doubts or anyone curious about anything to know.
Any queries or doubts, you can ask it in the chat or raise your hand, so we'll give you permission to unmute yourselves.
What do you mean by non-generative models? Uh, Anything based on AI that can generate something out of its own. It is called generative. What do you mean by non-generative? Ayush Bardhan. You can say.
You can unmute your mics. Acha, acha. Non-generative models are, suppose you have a model which does not generate anything, but it just returns data based on the data that you have fed in. It is not giving any innovative outputs, supposedly. I will provide you with a link. Yeah. I will provide you with a link where we have used a classification model to generate information from a given context. I will give you the link where you have to, you know, give a PDF file as input, and it will classify the information in that, and it will return answers. Stay tuned. We will just provide you the link. Any other questions or doubts relating to this or the discussion we have had so far? Okay, language models are probabilistic models. Like I showed you the example, honesty is the best. Then what? So, language models are models which return answers based on probability. Okay, like we give it a sequence of words, especially in language. We provide it essentially with some input words or strings, and it gives a probabilistic output which will match the input or complete the input. I hope Ved Aditya, I explained your question. Any other doubts, or if you could not understand any part?
Hello, hello, yeah.
Yeah, yeah, hello,
So
hello.
yeah, I'm Vedaditya. Yeah.
Yeah.
So actually, are generative AI models trained on language models and all, or like any other things are also they are trained on? Like suppose Bard is a generative AI model of Google.
Yeah.
So yeah, so like how is in short how the training really happens of these types of generative AI models? Like suppose Bard is one of them.
Okay, for training, there is something called deep learning,
Yeah, yeah,
where
yeah,
you
yeah, yeah, DL.
yes, there is something called deep learning, which uh, is so a little complex from general AI, but in using deep learning, you can use TensorFlow, PyTorch. These are the frameworks that you can use and train them. You can make your own models using
Like
deep learning.
like using the neural networks and all like yeah.
Neural networks and the RNN, CNN, all of that.
So I recently everyone I think has heard about Gemini. So it's is it a language model or like the data set on which Bard is trained?
Yes, yes, it is a model that on which the bird is now trained. The bird first trained on I said in the PPT like Lambda, then Palm, and now it is trained on Gemini. Yes.
It is a AI model actually.
Yeah. Right, right, right. Thank you, thank you.
Yeah. Any other doubts you have or anybody else has, can just unmute yourselves, or else we'll have to conclude the session. I hope we were able to say you everything that we know about generative AI, and hope you have had a great session. Now, coming to the end of the session, we have a next session on 19th January, which will be about pandas and numpy, two libraries of Python language. Uh, I expect a similar number of similar attendance there. Thank you everyone for joining. We have provided you a QR code. It will be visible on your screens. You can click on the, yeah, I mean, scan the QR code, and it will take you to a Google Docs. Can I have a raise of hands who have scanned the QR code and got into the Google Docs? You can just react if you have scanned the QR code. The QR code actually essentially has information about today's session and will update it about the upcoming sessions also. Yeah, please scan the QR codes. And if somebody is not able to find it, I'm just gonna share the link. So in the docs, Google document that I just shared, you have various options like you can see the source code and you can also see the slides. Yeah. There is a WhatsApp group link which will take you to the link of the AIML workshop, and you can join the group there, ask any queries, ask about sessions, give feedbacks or do anything. You are free to chat there. It's a WhatsApp group. I request everyone to join the WhatsApp group so that we can inform you more. And to the last part, we also have a assignment for today's session. The assignment is to make a chatbot using your OpenAI API key. You can generate your OpenAI keys at a website that I will just provide you in a second. I hope my window is visible. You have to go to this website called platform.openai.com/API keys. You'll have to sign in with your Google account, and then you will have an option to generate API keys. I have a key here, but if you want to generate your new key, you can just select this option to create new secret key. Give it a name. Suppose I give it a name as GenAI and generate. Okay, there is some problem. Yes. So when we go to this website, it will have option to create new GPT key. I'll name it GenAI and create a secret key. Here we got the secret key. You should not share this key with anybody. You'll have to just copy it once and you will not be able to view it next time. You have to just copy it. Remember to copy it, otherwise you will not be able to view it again. Done, and you have this here, and you have to give this secret key in your program. In the Google Docs that we have provided, there is a program named source code named source code 1.ipynb. You have to implement that in your code and fill the Google form. Is that clear to everybody? You can just react or raise your hands. Just a second, I'll guide you through the assignment. So this is the source code. You will get it at source code 100 IPONB in the Google Docs that we have shared you in the QR code. You have to just replace this with your API key. Like I have copied my API key and I will provide it in double quotations, and inside that my API key. Your API key will also be similar to this one. Okay, and you have to just run this model and it will give you some output. You can do it in the Google Colab itself, or you can copy this, do it in VS Code, or anywhere. You have to submit it through a Google Colab project. uh, in the Google Docs, there is a link for the Google form. You'll have to fill that form and provide this link. When you click on share, there will be an option anyone with a link, and view. You have to give it viewer right. Copy the link and paste it in the Google form. We'll have to just fill the Google form, and we'll get your responses. The people who will be able to finish all the 4 assignments that will be given will get a certificate from a GTSC VSSUT with your name. You can share it in LinkedIn or anywhere. You have any queries, you can ask in the chat or in the WhatsApp group that we just created. Join the group and ask if you have any doubts. Any more doubts or queries about the assignment?
Hello, hello.
Hello.
So actually, I had like a couple of doubts off this topic. Like, I had questions about like on a solution challenge that like that's posted in the GDSC group. So I wanted to know about that. So like, how does the team and all? How many members need to be there in the team and all? And what do we really need to do in the solution challenge?
Okay, you can ask about to the admins of the solution. You are there in the solution challenge group, right? Solution challenge info portal WhatsApp group.
Hello? Yeah, yeah, yeah.
Hello.
So,
Yeah,
so
yeah.
I can't really message in there. Like only the admins can message in the group. So.
Wait a second. There is a
Where you
group
can
called It Solution Challenge Info Portal. I'll send you the link now. Just a second.
No, he's saying that only the admins can message, but you can directly contact the admins for any further details.
all right. Thank you.
Okay, thank you, Pratipadma. Thank you, Ayush.
Thank you everyone for joining. I have shared the link to the Google Docs file also. You can refer to it for the assignment. Welcome, welcome. Thank you,
Thank
Chinmay,
you.
for joining.
Thank you, everyone.
Thank you everyone for staying till the end. So, with this, we conclude today's session. Thank you, Rashmi. We conclude today's session and we'll meet you in the next session, which will be on 19th January. I hope everyone will join that. It will be an interesting session and innovative work. We'll learn more about Python. If you have any queries again, you can please ask it in the WhatsApp group that we have created. Please make the session interactive. It will help you and us to understand more. Thank you. You all can leave the meeting. Good night.